Alright, we're going to look at nomenclature today. Nomenclature is the process of naming compounds as well as writing formulas for different categories. First of all, we'll look at ionic compounds. Ionic compounds are made from ions, kind of like the name implies. You should note there are two types of ions. Cations are positively charged because they have lost electrons, so now they have more protons. They're always listed first in the name of the compound and in the chemical formula as well. And examples of cations would be metals, hydrogen, and ammonium. So hydrogen is H+, the charge is +1, and ammonium is also +1. Next would be anions. Anions are negatively charged because they've gained electrons. They're listed second in the name. Examples would be nonmetal ions and oxyanions, which would be something like sulfate would be an oxyanion with a -2 charge. Opposite charges attract, and that's the whole idea behind an ionic compound, that a positively charged ion will be attracted to a negatively charged ion to form a compound. Here we have examples of cations right here, and then from left to right we have our anions. We can just do a few of these examples. We don't need to do every single one, but when we put these together we want to make sure that the charges must cancel. So we might need to have more than one of each ion in order to balance out. I'm going to start with this. Sodium has a +1 charge. As I look across the row here, so does bromide, it has a -1 charge. So in this case, the formula would be NaBr, where I have one of these to every one bromine, or bromide ion. However, if I want to put sodium now with phosphide, I would actually need 3 of these to cancel out the -3. So overall, this would be a +3 charge to cancel out the -3 charge. So then it would be a 0 overall. You wouldn't want to actually write these numbers in. I'm just showing it to you. So the formula there. Now with sodium and sulfide, it's a +1, -2, so I would need 2 sodiums to give us that +2 charge, with 1 sulfide to give us that -2 charge. +2, -2 would also cancel out. Last example, I would need here 3 sodiums to balance out that 1 nitride. We'll do the next one. Magnesium has a +2 charge, and look at sulfur has a -2. So here it would be a perfect ratio. 1 of each would cancel out perfectly. In this example where I have magnesium with phosphide, it would require 3 magnesiums to cancel out 2 phosphide. How did I know that? Well, 2 and 3 both go into 6. 3 times +2 is +6. A 2 times a -3 gives me -6. So those charges cancel out. Okay, and I'm going to skip around here. I'm going to go down one row. Gallium with a +3 charge, phosphide -3 charge. This would be GaP, just 1 of each. Okay, next, if I want to combine it with this one, +3, -2, the common multiple would be a 6. So I would need a +6 from gallium. I need 2 of those. 2 times +3 would give me +6. Sulfide, I would need it to be -6, so I would need 3 of these. 3 times -2 gives me -6. So this is how we go about the process of writing the formulas for ionic compounds. If you have any questions on the remaining examples, please ask in class. I'll show you the answers now. Here are all the answers for this page. There are 2 types of metals that you should know about. First of all, monovalent metals means that the charge will always be the same for that metal. When we name the metal and write the formula, just know that there's only 1 charge and we would never need a Roman numeral. So sodium, for example, is always +1. And so when you name a compound with sodium in it, you don't need anything additional, just sodium nitrate is the name. Another type of metal would be something called a multivalent metal. The charge would vary for the metal. When you name the compound, you would need a Roman numeral. So iron ion, for example, can be either a +2 or a +3. And so in this case, this is an example where iron is +2. The reason I can tell this is because nitrate, which is NO3, I'm going to write this over here, is a -1 charge. So if there are two of these, it would be a -2 charge overall, so this must be a +2 to cancel the charges out. Iron 3 nitrate, there are 3 nitrates, so then this must be a +3 charge. So two different forms of iron. Notice that they use a Roman numeral to communicate the charge of that metal. So the Roman numeral is the charge. It's not how many of them, just the charge. How can you tell if it's a mono or multivalent metal? You want to look at the periodic table that I've given you. In the bottom right hand corner, the charges will be listed. So if you look at nickel, you will see that nickel is also multivalent. Okay, some rules for writing the compound formula. This says identify the symbol and charge of the cation and write it down. Then you'll identify the symbol and charge of the anion and write it down. You will combine the cation and the anion into a neutral compound so it has no charge overall. We've already done some of those examples. So here we have 4 examples to look at. Get your periodic table and look these up. Lithium is Li, it's in column 1, so it is +1. Bromide is in group 17, and so it's -1. When I put these together, it'll be LiBr. Aluminum is in group 13, and that is a +3 charge. Sulfur is in group 16, and it's a -2 charge. When I put them together, it has to be neutral. So 3 and 2 both go into a 6. So I'll need 2 aluminums to give me +6 and 3 sulfurs to give me -6. Copper 1 means that's the charge +1. Sulfide from above is -2. So I would need 2 coppers for this 1 sulfide. Tin 2 has a +2 charge. Fluoride has a -1 charge. So when I write the formula, SnF2. Some more examples. As I'm looking at this, potassium is +1. Hydrogen phosphate is on your list. It's actually HPO4, and it has a -2 charge. When I put these together, it would be K2HPO4. The reason I need 2 potassiums is so that would give me a +2 overall to cancel out this -2. Sodium is +1. Bicarbonate is HCO3, and it's got a -1 charge. And I put those together, NaHCO3. One of these for one of those. +1, -1 cancels. Mercury 2, so mercury has a +2 charge. Phosphate has a -3 charge. So when I put them together, +2, -3, the common multiple is 6. So I need 3 mercury, and I would need 2 phosphate to give me -6. I put parentheses around this, so this 2 applies to both phosphorus and oxygen. The last example here, iron, is +3, as represented by the Roman numeral. Nitrate on your list of ions is NO3 with a -1 charge. 3 and 1 both go into 3, so I'll need a +3 from iron with just one of them, a -3 from nitrate by adding 3 of them. So you first name the cation, and second you name the anion. This is for naming the compound now. So the cation is either going to be hydrogen, ammonium, or a metal. And if the metal is multivalent, we'll need a Roman numeral. If it's monovalent, we don't. Next, we're going to name the anion. And if it's a monatomic ion, just one atom in the ion, then the suffix will be IDE, like phosphide, nitride, or oxide. If it's a polyatomic ion, you'll just name the ion. You don't change the suffix, leave it what it is. So here's some examples. And in the first column, we'll name the cation. In the second column, we'll name the anion. The ending would either be IDE, ITE, something like that. And if we need it, we'll put a Roman numeral in the middle for the charge of the metal. So K is potassium. Potassium is always a -1 charge, so I don't need a Roman numeral. And Br is bromine. When it's at the end of the element or compound, if I go back a slide here, it would need an IDE suffix. So it would be bromide. Next, the first one is calcium. Calcium is always a +2 charge. And O is oxygen, but we end it with IDE, oxide. Next, we have two similar examples here. These are both copper. If you look at your periodic table, copper is multivalent. Copper can either be +1 or +2, and you have to determine which one you have. So here we have copper first. The second element for both is chlorine, and we name it with IDE at the end. This is copper, and this is also chloride. So what makes these different is the Roman numeral that's necessary. So in this case, since there are 2 chlorides, then this must be copper 2 with a charge of 2 requiring those 2 chlorides. In this case, a 1-to-1 ratio means that this is just copper with a +1 charge. And here are a few more examples. The first part of it, NH4, is ammonium. Ammonium has a +1 charge, and this next part is something that has a -1 charge. This is called nitrate. The first portion here is called iron. Iron is multivalent. It can be a 2, 3, or 6. And then phosphate is PO4. Phosphate has a -3 charge, so this must have to have a +3 charge since there's only one of them. So it's iron 3. All right, this is potassium. It doesn't require Roman numeral because it's always +1, and this is sulfate. All right, this is sodium. It's always the same charge, so no Roman numeral needed. And this last part is something called acetate. You will need to review polyatomic ions for sure to make it more convenient to name compounds.